All right, triangle inequality theorem. So those individuals that were in class today, we used the spaghetti noodle to find out if you could make a triangle or not if you broke it in two places. So those that weren't here, that's too bad you missed that, but you can always try it at home. It basically says right here what we just came up with, that the sum of the lengths of any two sides basically have to be greater, not equal to, but greater than the length of the third side. Okay? So if we take a look at this one, if I gave you something that was, maybe I gave you a toothpick or something, or a piece of a spaghetti noodle that was 1 inch long, and then I gave you one that was 2 inches long and one that was 3 inches long. If I gave you those three pieces, physically gave them to you, would you be able to put a triangle together? No. The easiest way to do it, let's face it, you could pick any combination, but why not just take the smallest two? Okay, the 1 plus 2 we know actually is 3, correct? 3 actually equals the side of that last one. Equals not good enough. And that's the exact example we had where somebody broke it that way and you couldn't do it. Okay, so how about this one? Take the two smallest. Well, 18, again, if I gave you the spaghetti noodle or whatever, and add 21, you get 39. Is that good enough? Yeah, because 39 is bigger than 32. So you would be able to make a triangle out of that. And how about 11, 6, and 2? Well, the mistake some people make is they just add 11 and 6. Oh, it's 17. That's bigger than 2. No, you have to take the two smallest. So 2 plus 6 is 8. 8 is not bigger than the remaining, which is 11. Does that make sense to everybody? You got to take the two smallest. Is it bigger than what's left? Okay. And that's kind of what you did with your noodles. You found those two smaller ones and the one that didn't work, and it didn't add up to that longer one that you had. Okay. And so that's one very quick way to find out if you can make a triangle. Now, is this telling me if it's a right triangle or obtuse or acute or anything like that? No, it's just telling me, can I actually make a triangle or not? It doesn't tell you what type, but can you do it or not? This is an interesting process right here. I'm giving you the measure of two sides. So I'm telling you one of them that I gave you, one piece of spaghetti noodle was 21 centimeters, another one was 27 centimeters. I want to know what could the third side be that you could actually make a triangle. That's what I want to know. What's the range? From where to where? What size would it have to be? And the one good thing I do here is I use this word, and so does the book, and I like that because it makes the math a whole lot easier. Between. Okay? What two numbers must the third side fall? Well, let's try a couple numbers and see what happens. So if I know 21 and 27, so kind of back what we did in the last example, could the third side be, let's do a different color, could it be, say, 28? Would that make a triangle? It would, right? Because 21 and 27 would be bigger. So we know 28's good. All right, so that's good. And what if we tried 12? Is that still good? So 12's good. So it seems like we have quite a few options, right? So how do you think you can possibly figure out those options quicker than what we're doing? We could sit here all day, right? Yeah. Mm-hmm. Yeah, I kind of see what you're saying. She's saying add them together. And so if I add them together, let's try that. This would be what? 48. Now that particular setup right there actually is a no, right? But that's where this little word right here is awesome. It says between, so I'm not saying 48 is an answer, but anything less than 48 would work, correct? What if I use 47.9? Would 47.9 for that third side, would it work? How about 47.8? Those would all work, wouldn't it? So yes, if I'm saying between, 48 is our max, because you agree 49 doesn't work, 50 doesn't work, none of those work, right? So that's my max. Right here I'm going to put the minimum that it can be, but it's going to be between. That word is so awesome in this problem. Well, we know 12 at least, right? We just did that one, didn't we? Can we go any lower than 12? Yes, what do you got? Yeah, what if we subtract the two numbers? It'd be 27 minus 21 is, does 6 itself work? But does 6.1 work? It does, doesn't it? So now you see why that word between is great? Because you can say it has to be between those two numbers. Because you're telling me basically 5 does not work. But 6.75, we're good. 22, we're good. 57, no. 48, 6, because the word between. Okay, this is the quickest way to do it. Otherwise, we'd sit there all day. So then it makes this much easier. I would strongly recommend, because let's face it, this seems really easy right now. But imagine if you come back a couple months from now and try and figure this out. Maybe make yourself a note off to the side as to what you did. Add them together, subtract them, something like that, so you know what you actually did. Okay. Like I said, right now, this seems easy. Okay. So a little bit smaller now, maybe it's 5 inches and 11 inches is what I would give you. And then we have to figure out, well, how big could that third side be and still make a triangle? And so you would add them. So 16, is that the biggest or smallest? That's the largest, right? So, and then if you subtract, you get 6. So basically, you're saying 6 doesn't work, 16 doesn't work, but anything in between it does. Again, between. Now keep in mind, if I have a 7 versus a 15, those are going to make drastically different triangles. Right? They're not going to look the same. I'm just saying you can actually make a triangle out of it. I'm not saying what it's going to look like, but you can actually do it. Well, this is kind of a strange one. What's the range for this one? Between what and what? Yeah. Can you have 0? Can you put 0 down? Yeah, because we're using what word? Between. And 0 will actually be a side. No, but we're not saying that here, are we? We're saying 0.1 could be. We're saying 59.9 could be. Okay. So for this last one, we know at a very minimum it's what type of triangle? Isosceles. Could it be equilateral? Yeah, what side would I have to give you then? 30. And is it in the range? In fact, it happens to be right in the middle, right? Okay. So could number 5 here, could this one end up isosceles? Can it end up equilateral? No. Because this 5 and 11 is in here, right? So it could work. Obviously being 5, well, that's not going to be isosceles that way, is it? Can this one here, based on this, can this one be isosceles? Mm-hmm. Can it be equilateral? No. Okay. But either 21 or 27 could happen, correct? Okay, so just look for questions like that. Do you have any questions so far? No? Study the figure carefully and indicate whether each statement is always true, sometimes true, or never true. Justify your answer. It says, what do you got there? A 4, a 3, and a 2, right? It says dB greater than 7. Where's dB? Here it is. We want to know dB greater than 7. Well, what I would do is, do you see how we kind of have a lot of information about this side, correct? And so isn't that the third side of the triangle? So can't we figure out what that can be between? What two numbers it has to be between? Isn't that what we just did? So what does that have to be between, gentlemen?
1 and 7.
It has to be between 1 and 7 if you use the 4 and the 3. That's what we just did in the last example. This is applying what you just did. So can dB end up greater than 7 in this problem? No, because you can't actually form a triangle then. Do you see that? This can't be 7.1. This can't be 8. In fact, I could have said greater than or equal to. It's still never, right? Because 7's no good. Okay? So this is never. Why don't you try the next one on your own? Try BC being less than 9. Okay, walk around, see what you got there. I see some right answers. All right. The one answer I didn't see, and maybe I didn't come by you if you have it, I didn't see anybody that said never. But I did see both other answers. I saw sometimes and I saw always. Okay. Now, obviously what you're, hopefully obviously, is you get rid of that and you just look at the bigger triangle. So you got 4, 5, right? So then we can figure out what this has to be between. It has to be between 1 and 9. So now, here's how you have to read the question a little bit differently. This is saying that BC is going to be less than 9. Will the measurement that I put here, will it be less than 9? It will, won't it? It has to be, does this say anything about being between 1 and something? No, it just says whatever answer I put in there will guaranteed be less than 9. So that is always true. Okay. So watch out for those, because some people say, but 1 can't happen. That's not what it's saying. It's saying whatever answer I put over there is going to be less than 9. Okay, it's not saying that this is giving you all the answers. It's just asking, is this going to happen? And yes, it's going to be less than 9. Okay, so watch out for those types of questions. For example, I could change this question and say, is BC going to be less than 11? Is that answer over there still going to be less than 11? Is it, if I put a number here, will this number that I put here be less than 11? It will, won't it? See, you're thinking of 10, right? You're saying I can't put 10 there, but that's not what I'm asking. I'm saying once I put a number here, look at that number. Will that number be less than 11? It will, won't it? Every single time. Okay, you have to change your thought a little bit. Okay? Is any questions on that one? Because I do know there's one in your assignment that does try and trick you like that.